this is TanorTech, and today we're going to be messing with some vacuum tubes. So, let's come over here to the desk. Now, over here we're going to be messing with some vacuum tubes. We're probably going to be building a vacuum tube amplifier. I'm going to go through the whole prototyping process, and it's going to be kind of fun, because I'm just going to be hooking up parts to these vacuum tubes, or one of them at least, to eventually create a circuit that can actually amplify an audio source. So let me just put these away. I got out these vacuum tubes for the thumbnail. If you take a look inside this vacuum tube box, you can see that I have a lot of these little tiny vacuum tubes. Now these tiny vacuum tubes over here are these little tiny vacuum tubes inside here I got off eBay for about $40 total for all these. Actually, it was probably less than $40, but it was these and some more vacuum tubes, and I'm using these vacuum tubes for my projects. So the vacuum tube we're going to be messing with in this video is something called a C. Yep, that's right, Zachary Avenger, the power of eBay. Okay, so this vacuum tube we're going to be using inside this video is something called a 6CB6. Now this is a pentode vacuum tube, and that means it has three grids inside it, but 5 separate pieces. So let's take a closer look at what a vacuum tube is, kind of how it works and how it runs. So vacuum tubes are pretty cool. They were used in old-fashioned radios. In fact, I have an old-fashioned radio that uses a vacuum tube over here. If you take a look at this radio is a I'm not sure how old this radio is, but it's pretty cool. And if you look at the back, it has all these vacuum tubes. So these vacuum tubes are what run this entire radio setup. They're kind of like transistors, but... Okay, so cool. Someone asked, are vacuum tubes better than transistors? So, not exactly, but kind of. So, a vacuum tube and a transistor are actually pretty different. If I get out my transistors, you can see right here, this is what kind of a transistor looks like, and a fairly large transistor at that. And this is what a vacuum tube looks like. Now, vacuum tubes were used since the 1918s, probably, and they were used up until about the early mid-60s, probably. Now, the difference between a transistor and a vacuum tube is how they go about the process of amplifying a signal. So in a vacuum tube, you have something called a grid, and the grid is kind of like the base or the gate of a transistor or a MOSFET. So this is kind of a little circuit diagram of a vacuum tube. Now a vacuum tube has a few different parts inside it. Right here we have the cathode, right here, and right here we have a filament, and a filament's kind of like a little filament in a vacuum tube. We also have a plate up here, and we can have different amounts of grids in the center. Some vacuum tubes only have one grid. They're called triodes. Some vacuum tubes have 2 grids. Those are called tetrodes. Some vacuum tubes have 3 grids. Those are called pentodes. Now, the difference is this control grid at the bottom is what controls the current flow through this vacuum tube. The middle grid is the screen grid, and that helps accelerate the electrons. And the top grid is the suppressor grid, and that gets rid of some parasitic capacitance in RF circuits. But anyway, what happens is this little filament heats up this cathode right here, and it causes lots of electrons to go around it. And now all these electrons are accelerated to the plate because the plate probably has 100 to 500 volts on it, and it causes these electrons to want to move from here to here. Now, the electron flow can be controlled by this little grid right here by putting a different charge on it. So that is how we can take a tiny little audio source like this and boost it to a huge audio source like this. So you can amplify the music from a little phone to some pretty loud music. Okay, so let's come back here and start actually building some stuff. So we're going to be using this 6CB6. And now, whenever you build a vacuum tube circuit, you need to have a vacuum tube socket, because you can't actually solder directly to this little pins on the side of the vacuum tube. So what we're going to do first is we need to get a socket. Now you can get these sockets for pretty cheap on eBay, but that takes a long time sometimes. So I just made mine out of plastic, where I cut this little piece out of something, and then I drill holes with my soldering iron. Then after I do that, I can put wires in and hot glue them in place, so that way a vacuum tube can fit inside here. Okay, so now what we can do is we can test to see if the filament is working. Remember, the filament is a little thing that heats up. So I can take my bench power supply and hook it up to the filament of this vacuum tube. And as you can see, or see in just a second, when I turn up my power supply to 6 volts, because this is a 6CB6 vacuum tube, you can see that it'll start drawing some current. Well, maybe. There we go. So now the vacuum tube is starting to heat up. You can see that little red glow inside it. Now that means that this vacuum tube will be able to have electrons flowing around this little cathode right here to be controlled. Now what we're going to want to do is we're going to want to kind of make a circuit that allows us to connect this vacuum tube and to an audio source and let it amplify. So let me start by drawing another little diagram of a vacuum tube that's not so badly drawn as this one. So here's a vacuum tube. Here's our cathode. Here's our grid, our normal grid. Control grid is what it's called. Here's our suppressor grid. Screen grid, I mean. And here is our suppressor grid. Here is the plate. Cool, Zachary Avenger. He just said that he has a cool channel where he builds stuff. Cool. Okay, so now what we're going to need to do is design the circuit for this. So, typically, in RF circuits, this suppressor grid is grounded, but we don't really care about that right now, because this isn't an RF circuit. And also, the screen grid usually goes through a resistor to the power supply. So we'll probably put that through maybe a 1K resistor to whatever power supply we're going to be running it off of. Now, the plate needs to go through something called an audio transformer before it goes to the power supply, because this needs to be positive. Now, we could always just put a speaker right here, but a speaker has a low impedance of 8 ohms. So if I were to put a speaker right here, it wouldn't be able to drive this, because we have about 200 volts and a high impedance vacuum tube circuit. And so it wouldn't be able to actually drive the speaker and make it go back and forth and produce sound. So we have to have something in between. So we have something called an audio transformer. And an audio transformer looks kind of like this. And pretty much what it does is it has about maybe 800 ohms, which is a high impedance input. And on the output it has an 8 ohm low impedance input that can be coupled to the speaker that you want to play the music out of. Let me get a new pencil. This one's dying. So this will go up to positive right here. And this positive is going to be pretty high voltage, such as maybe 100, 120 volts. It doesn't really matter. But we're going to tie the screen grid to positive right here. So what happens is when we control the voltage on this screen grid right here, we can allow the current to flow from positive through this coil right here, through the vacuum tube with all the electrons, and back to ground. Now, this is pretty cool, because if we apply a tiny little voltage on here, the voltage that will come out of the secondary coil of this audio transformer will be a much larger audio signal. Now, what we'll need to do is couple this input into our audio source. So what we're going to do is put a capacitor right here, because capacitors block a DC voltage. Because a DC voltage on here will sometimes cause too much current flow, and especially if your phone or other audio source has a pretty high DC offset voltage, that won't be good for this. But the vacuum tube does need a DC offset voltage, and to do that we're going to put a resistor to ground, because we want it, if there's no music being played here, to bring this grid to ground so no current flows, because that would be kind of a waste of electricity. So we'll probably put a 1 mega ohm resistor from here to ground. Now we can also couple this little audio capacitor right here to whatever we're going to be using to connect this to an audio source. We can connect it to, I don't know, almost anything will work. Probably just a headphone jack, which I think the circuit diagram for that looks like. I think it looks like this. I'm not quite sure anymore. So anyway, that's kind of the circuit we're going to be trying to make today. And who knows if this circuit will work or not, so that's why we're building it. So if you look at this vacuum tube on the bottom, we're going to have a different pin out of where the pins are going to go. And so if we look right here, pin 1 is going to be the grid, or the control grid. Pin 2 is going to be the cathode down here. Now, pin 3 and 4 are going to be the two filaments. I didn't add the filaments in our little circuit diagram here, but that's what they are. Then 5 is the plate, which is up here. And 6 and 7 are going to be the control and suppressor grids. Now, we don't really care too much about these at the time being, because these are just going to be tied to positive. In fact, I think this one should go here instead of connecting to here. Okay, so that's kind of our circuit, so let's kind of start building. So first we're going to need to get some parts up here. So if you look inside my parts drawer, you can see that I have all my resistors organized very nicely. Sometimes they get a little bit bunched up. So we're going to start by getting our 1 mega ohm resistor. There we go, 1.5 is close enough. To the person that asked where's the cathode resistor to limit the current, we actually don't need a cathode resistor inside here. Sometimes in vacuum tube circuits you'll see a cathode circuit where instead of the cathode just being directly grounded, it will go through a capacitor right here, which will let the AC current flow, and then there will be a cathode resistor across that capacitor to actually bias the cathode. But for now, we're not going to use that. I mean, we could if we wanted to, but it's not really necessary. If you want, we can add the cathode resistor and capacitor to see the differences in audio quality. Okay, so let's get that 1.5 mega ohm resistor. That's important. Now, we're going to need to find an audio transformer and probably the other resistor. So if we go up here, we can find the 1K resistor. You can see it's nicely labeled. Find our 1K resistor that we're going to be using for the screen and suppressor grids. There we go. Those are our two resistors. Now it's time to go find some audio transformers. So transformers come in all shapes and sizes and varieties inside here. Now, we're going to want to find one with the right impedance. Sometimes that's a little bit tricky. So, a lot of times, when you're looking for transformers, you can find them, such as this, out of different circuit boards that come out of different electronic devices. So, it's kind of hard to find some. I got a lot of transformers inside here. Some of these transformers will probably work better. I think this one is actually from a vacuum tube circuit. It's an audio transformer. but I think I may have an audio transformer somewhere over here inside my pile of stuff to build a tube amp. So we're going to be using this audio transformer for our circuits. Let's measure some impedances of this audio transformer. So if I take my multimeter, set it right here, and then set it to ohms, we can measure the coils of this transformer to see what their resistances are. So when we look at the two long wires, we can see that it has a resistance of 300 ohms. So that's the primary side. And then I bet this secondary side is going to have a resistance of a few ohms. Yep, about 2 ohms. So this is the audio transformer we're going to connect our vacuum tube circuit to. Now we need a speaker. So let's come again. Oh, my tripod just broke. Let's come again here and find the speaker. This is my drawer where I can keep almost anything. This speaker looks like it should work. It's about 8 ohms, 3 watts. Okay, so we got a few components now. I think that should be just about all so far. All we need is the audio input capacitor. And we're going to need to build our power supply for this tube thing too. So if we come up here, you can see all my capacitors. We're going to want a relatively large value capacitor. And sometimes these are hard to find, but I'll find it. Here we go. That little capacitor there should work fine. Okay, so a few people asked stuff. Somebody asked if I had an Arduino, and I in fact have lots of Arduinos inside this drawer up here. I've won some from Instructables, I've gotten some from other ways. And someone else asked about my oscilloscope, and what kind. This one is a Tektronix 2232. It goes up to 100 megahertz, so it's a pretty good quality oscilloscope. So, now to build the power supply for this tube amp. Okay, my tripod's pretty broken. If you look right here, this leg of my tripod has actually come off right here. And that doesn't look normal to me. Well, it should still work. So what we're going to do is build a power supply. So let me explain how a power supply for this circuit is going to work. Okay, so someone asked why is the 3 grid connected to B+. I'm not sure. These 2 grids are connected through this 1K resistor to B+, because they need a screen grid resistor to accelerate the electrons. And they also need a suppressor grid to stop parasitic capacitance. But if we just tie these 2 grids together, it really shouldn't make much of a difference. So now to build the power supply. Because we're building a high voltage power supply, we can run this almost directly off 110 AC from one of those wall outlets that look kind of like this. If you're in Britain, they kind of look like this. Now, what you're going to need to do is take these 2 little sources from AC. You're going to want to put a diode on them. Now, DC and AC are different. DC is like this on an oscilloscope screen, and it means the current is traveling in one direction. It's flowing from point A to point B. Now, alternating current is when the current flows kind of like this, when it changes to going from one direction to another. So it would be flowing this way, and then it would be flowing this way. So this diode rectifies that current, and it makes it so that way it can only flow in one direction. And so now we'll need to put a capacitor right here. And this capacitor will reduce any audio hum. Now this capacitor needs to be electrolytic, kind of like this. Now if this capacitor is not rated at the right voltage or put in backwards in this little circuit, it's going to literally explode. So right here you see this capacitor as positive, this capacitor as negative right here. So the negative of the capacitor would be down here. Now this would be the power supply, and this would be positive, and this would be negative. Okay, someone asked, how do I win an Arduino from Instructables? So you just have to publish really good Instructables and enter contests, like the electronics contest or the power supply contest, and you can win a lot of cool stuff. So now, we kind of have our circuit kind of designed, so let's get our diode. So we'll go up here to the diode drawer. I have a drawer for just about every kind of electronic component. We're going to need to find a good diode to use. So typically, if you find diodes that say 1N 00 something, or 4N00 something, that will be their voltage rating. So this one is 4004, and that means it should go up to 1000 volts, which should be just fine for our purposes. So there we go. That's all the components we'll need. Let's fire up the soldering iron and start to get our circuit all ready. So here we have our 1 mega ohm resistor, we have our capacitor, we have our 1K resistor, our diode, audio transformer, a speaker, and vacuum tube over here. Okay, so we're going to start by getting a breadboard, because breadboards are pretty important to use too. Up here we have our little drawers with a breadboard inside one of them. Now, what we're going to do is we're going to start with our diode and connect this inside here. We're also going to need to take this plug and connect it to the variac, so that way we can get our power supply and we can get it to come into our piece of breadboard. So I'm going to be using some of these little connectors right here and some alligator clips like this. I'll connect one alligator clip over here, and I will connect the other alligator clip to another one of those little wires, and we'll connect that little wire right here, and we'll connect it right here. So this means that these two rails are going to be our AC power source. Now, I'll turn it on, and then these two rails are live, and that's pretty dangerous, so be careful. Now, what we're going to be doing is we're going to be using this power supply right here as our filament power supply. Now, the ground of this filament power supply probably shouldn't be touching the cathode of the vacuum tube, but even though if it does, we want the neutral of this to be the ground of our vacuum tube circuit. So if you look at these, we see there's a big little plug hole right here and a small plug hole. Now the big plug hole means neutral, the small one is live. So neutral goes to this wire, which goes to ground, and we'll have to move this one around, so that way we can put the diode from here to the positive rail of the power supply. That's where we're going to add our capacitor to. Okay, so Cool Boy Dude asked how I learned electrical stuff. YouTube videos, old books. Okay, so I just looked at this diode, and it's kind of hard to fit this diode into the breadboard. So we're going to have to get a different diode that'll work better. A different diode that has longer pins. Those little tiny diodes work when you're just soldering stuff together, but we're going to need some bigger diodes for now. If you look at this one, if it focuses, this is another 1N004. So it's the same kind of diode as this, except it's longer, which allows us to connect it into the breadboard. So we're going to take this negative rail and positive rail, and we're going to have this go from AC live through here into the positive rail of our breadboard. Sometimes it's a little bit tricky to get that in. So then the current will flow through this diode into the positive rail and charge it with a positive voltage. Then we have ground going straight to neutral. Okay, so that makes sense. Now we're going to have to wire the capacitor. Now this capacitor doesn't exactly fit into these terminals of here, so we're going to have to make a little adapter that lets us do that. And for that we can use some old resistor leads. So this resistor was in my dead resistor pile, and I'm not quite sure what value it is. But you can cut off these leads right here, and you can connect them to the capacitor, so that way you can use it to connect to your breadboard. You can also use more of these little wire things from this wire bucket that I have right here. I cut some of these wires apart, so that way I could hook them onto this capacitor. But you know what, for now, I'll just solder them. So we'll take the soldering iron, and we'll kind of tin this little metal lead right here. And we'll connect this little metal lead to one side of the capacitor. Now we'll just need to get another metal lead to connect to there too. If I can find that resistor. The resistor seems to have disappeared. Okay, we'll use another worthless resistor right here. I have plenty of those anyway. We'll then solder that to the other side of the capacitor, so that way we can actually connect the capacitor to the rails of the breadboard. Okay, that looks good to me. So you can see that this capacitor has a negative end and a positive end. And so what we're going to do is bend these little leads down. And we want to bend the negative lead down closer to the capacitor, and we want to bend the positive lead down farther from the capacitor. This allows us to connect the negative lead into the negative rail of the power supply, and the positive lead into the positive rail of the power supply. This way, when we charge it up, this capacitor will charge correctly in its right polarity. So let's fire up this little variac. Nothing's exploded so far. Now when I turn it off and I discharge this capacitor with my pliers, you should probably see a spark. There you go. That means our power supply is working correctly. So now it's time to hook it up to our vacuum tube circuit and start building it. So right here we have our vacuum tube, and the bottom one right here is the grid, and so we're just going to tie the grid right here. This top one is the cathode, so we'll put that cathode directly to the ground pin. Now that leaves us with 3 more pins on the vacuum tube, and those pretty much can all be connected together. So these bottom ones are going to be connected together and tied through a 1K resistor to the B plus or power supply. And this one is the plate, and that's connect to the audio transformer. Okay, cool. Let's get some pieces of wire and connect those together. I know I have some cut pieces of wire in here somewhere. I can probably just use this wire right here. So I'll connect this wire via a solder joint to these 2 bottom pins. And these ones are the plate and the suppressor. And this can be tied to the resistor to B+. So I'll kind of tilt this thing up a little bit and solder it together. Sometimes soldering is not the easiest thing to do. Especially when wires don't cooperate. Like now. There we go. So I can connect this little wire all the way up to this little piece of metal right here. There we go. This vacuum tube can now be connected to this little pin right here. Then we'll take our little resistor. This resistor is 1K. And we'll bridge that to positive from that little wire right here. This should allow us to connect this screen and suppressor grid to positive through a resistor. That should work. Now let's tie the plate into this audio transformer. Now I've kind of forgotten which one has the low impedance and which one has the high impedance. So I'll have to check that again. Seems like the two long ones are high impedance. So I'll connect one long wire from this audio transformer into positive of the rail here. And then one lead to the plate of the vacuum tube with some solder. Right here. Like I said, sometimes soldering with a camera right in front of you is kind of difficult. Sometimes soldering old wires is difficult too. Okay, you know what? That's not working very well. We're just going to be using this alligator clip to connect the audio transformer to here. This is going to be our plate supply. Now also you want to make sure that none of these other connections short out. Because if they short out, that's not good for you, because that could ruin your vacuum tube. It could cause it to arc over. You want to make sure everything's nice and separated. There we go. So now we're going to take our capacitor and connect that to this wire right here. This wire is going to be our grid. So we'll put that capacitor there. We're also going to bridge the grid to ground with this 1.5 mega ohm resistor. This will negatively bias the grid, so that way it will work better and cause the vacuum to be more efficient. So now all we have left is one more little connection point. And this connection point is where we're going to connect our audio source to. We're also going to need to have a ground connection point for the other side of our audio source. Okay, this is where we connect our audio source to. So we have negative going here, positive going to the capacitor. And there we go. Okay, someone also asked if I have a fume extractor. And if you look down here, I do have a fume extractor that I built a few videos ago. But this fume extractor seems to have broken a little bit. This side part, I made the mistake of using hot glue to put it together. And eventually, before, this fume extractor was pretty cool. It was pretty powerful and sucked all the fumes through this little grate on the top. But it's kind of broken and I haven't used it for a while. So that's the story about that. So what we're going to do now is find a little headphone jack thingamajig and connect that to our breadboard. Sometimes I lose stuff on my desk, including this little headphone jack. Right here. There it is. So here's the headphone jack. We have this as ground, and we have these two as positive. We're going to put this one just away because that one doesn't matter for now. So this headphone jack is how we can connect our vacuum tube circuit. Now we have one more thing to do before this circuit is actually ready to function. We need to connect our speaker to the output jacks of this audio transformer. Then we can fire up our whole circuit and hope it doesn't explode again. So we'll use some of my favorite alligator clips. And we'll use those to connect the speaker to the output terminals of this audio jack. There we go. Now, our circuit is very shoddily put together, but I think everything should be correctly hooked up. I'm pretty sure. I think. Okay. let's start by firing up the filament. We'll fire it up to about 6.3 volts. And we need to wiggle around the vacuum tube, so that way it actually draws current. I guess sometimes it's not playing very nice. Then after the vacuum tube is fully heated up, as you can see, when the current stops dropping, then we can turn on the V+. Oh, there we go. If you listen to the speaker, you can hear a 60 Hz hum. When I touch this thing, you can hear the 60 Hz hum increase. Cool. So if I touch this wire, you can hear the speaker make some nice hum. Okay, cool. So now, let's give this thing a practical test and hook it up to some kind of audio source. I'm pretty sure this is okay to connect. So I'm going to go get my old iPod. We're going to try to play some good old Tanner Tech videos. Okay, that's not turning on. Looks like it has a dead battery. Let's get a Walkman to play some music through. See if we can get it to work. Okay. We'll turn this on, plug it into the headphone jack, and hopefully we'll get some noise. Oh, there we go. Well, it looks like we're actually getting amplified signal out of the speaker. Right now it's playing some talk radio, but as you can hear, it's being amplified actually very well by the vacuum tube. Right now this is just the AM station that does sports, but you can hear that it's actually playing through the speaker. Now I'm thinking the speaker is too high impedance, because it's not being very loud and it doesn't sound very well. So let's turn off this Walkman and go get a lower impedance speaker, because the lower the impedance, the more current it'll draw at a certain voltage. So that one is 8 ohms, so we need to find a 4 ohm speaker, hopefully. I'm thinking this one is 4 ohms. 12 ohms, not going to work. 4 ohms, looks like we're using this speaker. So we're going to take this audio transformer and disconnect the speaker from it, this speaker at least, and connect this bigger speaker with a lower impedance. Hopefully we should get some better results. So I'll remove this speaker. This one is not going to work for us at the time being. Connect to the speaker. There we go. I think I hear. There, that's better. That's some pretty good quality. You can hear that there's almost no hum, and it's pretty loud. So there you go. That's kind of how you prototype and build a vacuum tube circuit. Now, if anybody is still watching and has questions about what to do to make this circuit better, or if you have any suggestions for what to do here. Now, this largely depends on voltage. Right now it's running at a pretty low voltage, and so it's not going to be as loud as if it had a higher voltage from a better transformer. But this should be good for now. Actually, this variac can go higher. Let's try that.
Davis, the veteran center fielder,
as you can hear, when I turn it up, the sound gets louder. When I turn down the supply voltage, you can hear it get slowly lower as the capacitor discharges. That's amazing. It's still working down to 50 volts. Still amplifying. And it works better when you go higher.
Has really kept Rajay Davis in check coming into this game. 2 for 24 this year against the Angels, and he is the guy that you do not want on the base pass. He will run and run often.
Well, that's pretty cool. The vacuum tube is actually amplifying the audio signal from here. So you know what? Let's get an oscilloscope inside here and test some of these input and output voltages to see what we get. This will actually prove that this amplifier is working very well. So I'll fire up my scope. I'll find my probes that have somehow disappeared. And we'll try to set this up so that way we can see both of the input and output audio signals. So we're going to set both of these to AC. We're going to set mode to both, set this up a little bit, and we're going to connect our two probes from the oscilloscope. Probe 1 is going to be here. And that's set at 50 volts. We're going to set this at 2 channels. And hopefully we can get our 2 channels separate. And then we can connect both of these oscilloscope probes to the 2 channels and measure the input and output audio voltages. I'm hoping this will work. My oscilloscope hasn't been cooperating the past few days, so I'm hoping this will... There we go. Now we have our 2 different audio signals here. So let's start by connecting our channel 1 audio source to the input from the Walkman. So we'll take this and we'll try and connect this to this little pin right here. We'll try and connect this one to ground. I'll have to find a ground lead. Then we'll have to adjust channel 1 so it's a little bit of a lower voltage. There we go. We can see the little alternating current voltage on channel 2, which is the voltage that is coming out of the Walkman. Okay. I'll turn down the volume of the Walkman, and we can connect our second oscilloscope probe to the actual output of this thing. So this is kind of a little bit tricky. Okay. Something's not right. Okay. This is a little bit confusing sometimes. It's kind of hard to do in front of a camera. Oh, cool. Novinoid. You made a video on how to make a Geiger counter from a camera? I'll have to check that out after. Okay, so we've got this probe connected to one of the sides of the output of the speaker. So I'll need to find my other oscilloscope thing to connect it to... There we go. This is something you need. Hey, Brian Esba. So we'll connect this to here. And we'll connect that to here. So the oscilloscope is connected here. Oh. We'll connect that here. Okay. So now here we have both of them at 0.5 volts. And then you can see the 2 audio signals side by side. So if we look at this oscilloscope, we can see the difference in the audio input and the audio output. If I turn up the Walkman, you can see 2 audio levels. And as you can see, I think those 2 audio sources are inverted, because you can kind of see it like this. Okay, you know what? I need to get a signal source from from something else. Let me turn this off. Okay, so whoever's watching right now, I'm going to be right back because I need to grab my laptop as an audio source to connect this to, so that way we can see two different sine waves on here, because that's a lot easier to compare than a radio signal. I'll be back. Okay, so I've actually just plugged in this old iPod to charge. We'll use this as our audio source as soon as it finishes charging up. So let me just turn on the Walkman again, so you can see our two little audio waves inside here. So this vacuum tube right now isn't very, isn't amplifying it very much. As you can see, both signals have about the same amplitude if I move them around. But this one is 0.2 and this one is 0.5. So that's about maybe, I don't know, maybe like a 2 decibels of gain. And 2 decibels of gain isn't that much. But that's because we have one vacuum tube, which is a small vacuum tube, and it's not actually really meant to drive an audio transformer like this. But still, for being a tiny little vacuum tube, it's doing a pretty great job. So normally, if you look at other tube amps, kind of like my tube amp that's down here, you can see that I have one vacuum tube and two vacuum tubes. And so this vacuum tube right here is a 12AU7, and what this does is it has two separate triodes inside. So those both amplify the sound twice, and each one is 100 decibels of gain. And then that goes into this final driving audio output, and that drives the audio transformer. So that's how this tube amp, which is one of my first ones that I ever built, gets so loud. So someone asked, is it possible to build a headphone amp with a 12AU7? Yes, it is. This amp is built with a 6CB6. So there are two different types of devices, but two different types of tubes, but you can pretty much build the same stuff out of both of them. But as you can see, it's working pretty well. I'm really hoping that my signal generator will start working soon, so that way I can use it. So in the meantime, we can try to get a higher voltage on this vacuum tube to see if we can get some higher audio output, hopefully. So what we're going to need to do is get an auto transformer. Or, lucky for us, we have something down here that I made quite a while ago, and I'm hoping it still works. But this I made in a previous video, and it's a power supply for vacuum tube projects, and it connects to my auto transformer down there, so that way it can supply voltages that are actually isolated from the mains for vacuum tube sets. And I can run this off 170, 280, and forgot what that was. I kind of forgot how to use this switch. But I think that if I set this to here, then I set it to this switch. And if I set it to here, then I set it to this switch. So we'll try and connect that up, so that way we can get some higher voltage and see if this higher voltage will make this thing run better. Note to anyone who is trying to build something, I probably wouldn't recommend using hot glue to connect their projects together, because it doesn't stay too long. So we're going to try and connect some of our power supplies up here. So right here we have our positive and negative rails, and these positive and negative rails will connect over here to our input for this. And so that way we can hopefully get some higher voltages and hopefully some louder sound. But first we'll have to look at the voltage, or the plate voltage, of this vacuum tube to make sure we're not overloading it. I also need to make sure that this tube thing is actually working. Kind of forgot. Yep, it's got power. As you can see, the neon light's on. So, as you can see, that probably charged those 2 points right now when I turned it on. So, oh, there you go. You can see that shorts it out. It sparks. So we're going to connect this with 2 large alligator clips over to our power supply. So the first one we're going to set is we're going to set this to set the PSU. Actually, yeah, set by PSU. And this is going to be, I think, 150. Actually, I forgot something. There's a switch on my PSU. So I think we're going to try it 150, which is low. And it's on low right now. So we're going to have 150 volts on those 2 pins. So then we can try and switch it to this and try and get some higher voltages. So I'll connect this wire right here to ground. And then we'll connect ground way over here to this ground of our power supply. We're then going to run a wire from positive, which is down right here. We're going to run that wire over to positive from our power supply. This will eliminate the need for the variac inside our circuit, and let us achieve higher voltages. Okay, let's turn it on and see if it's still running. Oh. As you can hear, we still have some sound. Okay, so now that that's working, let's check see what happens if we crank up the voltage. I'll flip the switch up. There we go, it's slightly higher of a voltage. Still kind of sounds the same. If I put my hand on this, my body acts as an antenna. It makes it louder. So let's crank it up to the highest one. Let's crank it up to the highest voltage we can. Okay, we're at the highest voltage. I don't hear much difference. I don't think it's making a difference. The higher voltage is not really making a difference in the sound quality or sound output power. So I'll turn that off. And as you can see, it's pretty cool because even though that's off, the circuit draws so little current that this capacitor is still staying charged for a while. And then as you can see, when the voltage slowly dies, then this speaker slowly dies out too. So we're going to disconnect our power supply from here and just run it off the variac again, because that seemed to be working pretty well. And we have our signal generator source, which is the other phone that is available to be ran. So I'm going to scoot this a little bit over here. And we're going to try and see if we can get some better quality on this thing. Oh, that's funny. Look at this. On my old iPod, you can see that it says watch live now, Tanner Tech playing with vacuum tubes. That's pretty funny. So we're going to go to Safari inside this old thing. We're going to try to find we're going to try to find a tone generator. So we'll look up tone generator. Cool. And I'm not sure what that is. Okay, this is going to be a tone generator website, and this will generate a tone for us to use in our circuit, hopefully very well. Let's turn on this power supply one more time, just to make sure it's still working. As you can see, that oscilloscope is still working with Walkman. But now we're going to try the tone generator. So I'll turn off the power again. And we're going to disconnect this and connect it to the iPod. Now I think what we're going to set it to is maybe 1440 hertz sounds about right. And you can hear that sound playing. So we can change that little signal right there to maybe 1 kilohertz. 1 kilohertz should be better. So we'll connect that up to our thing right here and to our circuit, and we'll see how much that amplifies. First, I'll need to take off this cover for this phone, so that way we can actually hook up the headphone jack. So we'll scoot aside this Walkman, turn it off, and we'll connect this phone to the same place the Walkman used to be connected. And I'm hoping it won't burn out the old phone. There we go. If you look on that oscilloscope, you can see the little signal being played right there. If I turn on the power, you can see that we have our two different waveforms, which is pretty cool. Now, there's something special about these waveforms, and I'm going to tell you in just a second what that special something is. Right now, it's not very loud, because they're relatively small waveforms. Right now, one is set to 0.1 volts and one is 0.2 volts. Right now, they're both at 0.2 volts. The bottom one is the output, and top one is the input. So if I scoot these together, you can see that it is indeed amplifying it about twice. So the cool thing is, if I set these both to the same level, or just about the same level, you can see that it's cool because when these collide, they form this really cool little wave right here, because it is actually doing something called inverting the signal. Because whenever this is positive, this is negative, and vice versa. And it's pretty cool to see this. It looks like, you may not be able to see this on the camera frame rate, but both of these little audio signals are on top of each other, kind of like that. If I press store, you should probably be able to see it better. So there you go. That is pretty cool. That's showing you that this audio amp is actually working, because if I was just playing the music straight from my iPod into the speaker, you would see these both in the same phase, but they're 180 degrees out of phase right here, because the vacuum tube is actually inverting the signal. So that is actually pretty cool to see. Nice. So there's one more thing I was going to try, and that's to set this to XYZ mode, and we should get a perfect circle because of Les Ajou figures. So if we go here and we try to do XY, there we go. We've got kind of a perfect circle right here. Now, the reason why the circle looks so weird is because since they're 180 degrees out of phase, it kind of squeezes the circle together. If they were in phase, then it would look something like this. There you go. That's pretty cool. Since they're both about the same, you can see this little line right here that's being drawn. That's because both of the things are in phase, and it's pretty cool. Let's take it out of XY mode, and we can view those two signals together. So when two signals are 180 degrees out of phase, and you put it in XY mode, it'll make a perfect little line in the circle. That's not good. Sounds like something's crackling or popping. Huh. Oh, okay. Gotta turn that off. I don't know what's going on here. I hear something popping, and that's not good. Let's disconnect this from power. That's still storing it. Hoping nothing happened. As you can see, yep, arcing, that's Yeah, I'm not sure where that's happening at, but there's definitely art going on. It looks like we may be done for the day. That's cool. We got about an hour of live streaming. And that's how we kind of built this little audio amp. As you can see, the iPod's still putting out a signal, even though the audio amp is dead right here. So, that thing probably had between 2 and 10 decibels of gain, this vacuum tube did, and amplifying that little signal that we had into quite a bigger signal. So that's pretty cool. Oh. Okay. So here's our full circuit right here from above. You can see that we have a vacuum tube here. Just about everything else. The audio transformer, the speaker. And we were able to listen to some cool music from that Walkman somewhere. We were able to see how the vacuum tube was actually able to phase shift the signal on the screen. Let me show you about that phase shifting, because that's kind of important to know. First, let me discharge this capacitor, because, yep, they always hold a charge. So what happens is inside the vacuum tube circuit, when a positive voltage is applied here from the signal, so when the signal is at its positive peak, then that means this grid is very positive. And when that grid is very positive, it will not want to let any more electrons flow through here, because the electrons are negative. And so if this is positively charged, they'll bounce off. Now, when it goes into its negatively charged little region of this thing, then that will make it so that way lots of electrons are able to flow. Actually, that's not right. That's opposite. Oh, never mind. When it's at the positive region, then this is very positive, and it makes the electrons speed through faster, so it makes more current flow through here. Actually, I forgot why it phase shifts. Forget that. It works somehow. I know that it has to do with the charges on here. And, cool. So that's how to make this little vacuum tube circuit, and you can see how the thing's phase shifted. My tripod is still broken. As always, thanks for watching. Stay tuned for my next video. So in my next video, I'm going to be showing you how a microwave actually works. So I'm going to be taking apart a microwave and showing you how the insides of the microwave actually function to warm up your food. And I'll explain the circuits and stuff too. As always, thanks for watching. Stay tuned for next time.